Welcome to this series of videos where we talk to Dr. Warren Corns, who's Research and Technical Support Manager at PS Analytical, about mercury and the various issues to do with mercury in the environment and analysis of mercury. Okay, so we've looked at getting mercury from solids and liquids into the instrument in a gas form to be measured, but obviously there are gases we want to measure mercury in, like natural gas or in the air around us and things like that. How do we go about getting it from the gases that we want to measure it from into a form that can be measured by the instrument?
Mercury in a gas sample would normally be present as elemental mercury. You can get small amounts of reactive gaseous mercury and organic mercury present in gas samples as well. And so we need a method of pre-concentrating those mercury species in air before we do the atomic fluorescence measurement. And this is particularly true when the levels are very low. So what we use is a gold trap, which I've got one here, which is essentially gold impregnated onto silica, so it has a very high surface area. And when you pass a gas sample across this tube, the mercury compounds collect on the gold surface by an amalgamation process. And this type of trap will collect all forms of mercury, so it's considered as a total gaseous mercury measurement. And so the mercury species collect on here and pre-concentrate, and then after a period of time, when we've collected enough sample, we would put this into an analyzer and do a thermal desorption. What this does, it basically releases the mercury compounds from the gold into a flow of gas, which then flows into our atomic fluorimeter. And the beauty of this is that you can collect different sample volumes. So if we're dealing with a very low concentration, we can collect a larger sample. If the concentration is very high in mercury, we can take just a small sample. So we can actually change the sample volume to cover a very wide linear dynamic range. The other advantage is that this is very selective. We'll only collect mercury forms, and therefore the measurement is free of any spectral interference. You won't get interference from any other gas species present. For that reason, we can use this in quite complicated gas matrices, for example in mercury in natural gas or in flue gas from a coal-fired power station. So this additional sensitivity that you get from pre-concentration selectivity offers very reliable measurement.